Okay, now let's hide this TP. Close this. I'm going to copy this into another TP. And with this, I'm going to explain the optimizer, the remove A cut inside the optimizer. Okay, before I do this, I will create a new cutter. And okay, so I will highlight this to copy the parameters and click the new cutters and EM12 done to 12 and the rest is okay. Let's check again the cutter. Where is my EM12? Okay, not here. Let's do it again. EM12 and I have 12 diameters. Okay, again, is it inside here? Yeah, there's my new cutter. So I'm going to use this cutter here to cut this part. Let's go top view. You and go to screen and you can see this cutter is very big. So some area the cutter will not cut. But okay. Now I'm going to edit this process now. Okay. And so I will say EM12. I'm going to change this and change cutter 12 and okay. And in this case, I'm going to off the optimizer and calculate. Right, you can see after this big cutters, you have, let me check the remaining stock. A lot of unmachined stock this area, right? A lot, right? This area, and also the whole region over here is not machined by this big cutter. Yeah. So next, how to solve this? I will show you. So I'm going to copy this process, and now I'm going to change to a small cutter, right? I'm going to use the MU8, and now maybe the clearance I'll change to incremental because for second roughing a lot of jumping. Okay, and now I'll calculate. Yes, as you can see, if I don't use the optimizer for the small tools, let's say remove A. Okay, I will have a lot of let's check for the remaining stock, the previous one, remaining stock, and you can see here, right? A lot cutting here, unwanted cutting, air cutting will happen. Okay, yeah. So I'm gonna on the optimizer now. Use the optimizer, and I'm not gonna use a cutter. Holder go check cancel, period cancel, rapid motion go check is okay for me. And this is the one, remove air motion. Just click and calculate. Okay, do you see a difference? Okay, those air motion at the middle is automatic remove. Okay, so I'm going to simulate. Okay, now let's see. You can see the cutter only cut those material remain, not the air. So this will greatly reduce the cycle time for the second smaller cutter for the roughing process. Okay, so that is the remove air motion in the motion optimizer. Okay. Okay, you might ask me what is this cut by Z limit? Okay. This is mainly for the 3D functions. 3D functions because in 3D cutting some of the function we cannot limit by the Z. Okay. Then you can limit by the Z down or limit both the Z down or Z top, so that you can cut between let's say -5 to -10, things like that. But with the two adaptive functions, we have this z top and z bottom. I don't think you need to use this cut by z limit. Okay, so you can ignore this. Okay, now I'm going to talk about tolerance and approximations. Let's use sketcher and placemeter button to enter the XY planes. And I'm going to sketch a ellipse. Yeah, in this case, let's put it to 100 and the Y 50 angle at 0 and put it somewhere over here is okay. Okay, let's change this color to black. Right now, I'm going to create a new TP for this. New TP is okay. I'll put this to TOL and blocks. Okay, that's command. And I'm going to create a profile position now. Go to 2.5 axis and profile close contour. And I will select the ML8 cutter. Right, and contours I'm cutting outside. Okay, right. The next I will maybe use a tangent approach. Yeah, this is okay. The clearance is okay. Entry is okay. The boundary is okay. And let's look at the top. We're going to machine from 0 to maybe minus 10 mm. Right. Downside plus I'll put to 10 mm. Coding machining one pass. Maybe it is a climbing milling. And now the last one that I want to understand is the tolerance. Okay, let's say now I put the tolerance to be 0.1 and let's calculate. Right? And I'm going to put it here TOL 0.1. And I'm going to copy again this process. Copy here. Change color to this one, yeah, and I will change this to 0.001. Okay, so I'm going to edit the second process and change the tolerance to 0.001. Okay, so I'm going to show you the difference. Let's look at the result. Zoom in out. Do you see the purple profile? Is very smooth. It is very smooth, right? Because the tolerance is very tight. It's 1 micron, yeah. And if you look at the blue curve, it is not smooth, right? Not smooth. So steps, right? Steps. And if you compare to the 1 micron curve, you will have one gap here. And this gap is the maximum, is the tolerance. So if you put in a 1.1 tolerance, that means the gap here will not larger than 0.1. This is the meaning of tolerance. Okay, so the smaller the tolerance, the smoother the profile. That's the difference. So another difference is how to compare. I will show you. First, I'll post out this same process. Okay, numbering, yes, same process. Let me change the name. G code and 0.1. Okay, this is the 0.1. Now I'm gonna post again the second one. This time, this is 0.001. Okay. So you can see, okay, you can compare now. Okay, so if you use 0.1, because the point-to-point distance is short, so the number of lines is only 80 lines. So if you use a very tight tolerance such as 1 micron, the point-to-point distance will will be very small and the result is very smooth, but you have a lot of G codes. Yeah, this cannot be avoided. That's the difference. 676 and 80. So now you understand what tolerance means. So this the only time that we need to set the tolerance to control tolerance is during finishing. So finishing, make sure you key in a good tolerance so that the result will be smooth, or else you can see steps on your part on the surface. Okay, now I'm going to talk about approximations. Let's hide this linear. Okay, so this process here is created with, let's go to motion parameter, linear approximation. Do you see this? Yeah. I'm going to copy this, put here, and again change color maybe to this. Yeah. And I'm going to change this to circular. And I will edit the parameters. Go to the circular approximations. What is approximations? Let's put. If you don't know, you always can press F1. Of course, you have a nice picture to show how to explain. So you have linear and you have the circular. And if you choose the circular, what is the angle of normal means? Right? It's explained here. Okay. Now, so just now is linear. Now I'm going to change to circular. Angles are normal. Default 1 degree is okay. Just calculate. Okay. Now, what is the difference? Let's go to top and see. Okay. There's a difference. Okay. There's a difference. There's some difference. Okay. So the blue line is connected by a straight line, G0 straight line. The purple color now is connected by circular, by arc, or by G02 or G03. So I will post this. I will post this process and post, and it change the names. Okay. Okay. This is one. Again, I will post this. Okay. And post and get a circular approximations. And now let's compare the 2G code, right? So in linear approximations, all you can see is G1 motion, G1 connected straight line to straight lines. Okay. And this is the circular approximations. And you can see here, instead of G1, it is using G02. So it is connecting the whole profile by arcs. That's the difference.